Right now, we are witnessing a crowded, highly competitive rush back to the lunar surface. NASA has massive Artemis rockets rolling out to the launch pad, while international space agencies and private companies are actively preparing their own fleets. Contrast that frantic activity with the historical record. For nearly 40 years, humanity entirely abandoned lunar exploration. The moon slipped completely into the background. So why this sudden urgency? To understand this stampede, we have to look at the specific event that made the global space industry pivot its attention back to a rock written off for decades. In the years immediately following the Apollo missions, the scientific community made a collective decision about our nearest neighbor. Researchers thoroughly analyzed the physical material brought back by astronauts. The data was definitive. The lunar rocks were completely dry, ancient, and geologically inactive. This diagram illustrates the tyranny of the rocket equation, the exponential fuel required to lift mass from Earth's gravity well. Without local water, launching life support is financially impossible. Consequently, space agencies turned inward, focusing strictly on low Earth orbit stations. The scientific record remained settled for decades. As long as the moon lacked water, it held an economic and strategic value of 0 for the long-term survival of human spaceflight. That 40-year consensus held until 2008, when the Indian Space Research Organization launched the Chandrayaan-1 orbiter. The mission team did not let the Apollo-era assumptions stop them from looking for new data. The probe carried a collaborative payload. It included ISRO's proprietary spectrometer, alongside a highly specialized NASA instrument called the Moon Mineralogy Mapper. This chart shows the light reflecting off the lunar surface, and it reveals a massive anomaly in the readings. These downward dips in the graph are spectral signatures. They represent exact wavelengths of light being absorbed by hydroxyl and water molecules embedded directly into the lunar minerals. These subtle fluctuations in the data were the very first cracks in a 40-year-old scientific doctrine. The instruments also revealed that these resources were not distributed evenly. The spectral signatures grew significantly stronger as the orbiter scanned the regions near the lunar poles. Near the Lunar South Pole, there are deep craters that are permanently shadowed. Sunlight never reaches the floor, and temperatures remain unimaginably cold. In these extreme conditions, scattered molecules accumulate into billions of tons of solid ice beneath the regolith. Chandrayaan-1 also identified widespread deposits of helium-3. Theoretical physicists point to this rare isotope as a highly prized, highly efficient fuel source for future nuclear fusion reactors. The scientific community moved carefully. The NASA team published their initial findings first, prompting ISRO to rigorously reanalyze their own internal datasets to independently verify the discovery. That abstract orbital data received physical validation 15 years later. In 2023, ISRO's Chandrayaan-3 successfully executed a soft landing near the South Pole, delivering direct surface-level proof of regolith behavior, thermal properties, and seismic activity. The initial hypothesis from the 1970s was officially obsolete. The physical measurements proved the moon is an active, resource-rich environment. A massive reserve of lunar ice solves a critical engineering problem for deep space exploration. This ice provides the raw material needed for both life support and propulsion. This basic chemistry makes deep space travel possible. When you have water, it can be split into its component parts. The oxygen is routed into life support systems to provide breathable air, while the hydrogen is isolated and processed into highly combustible rocket fuel. By extracting and manufacturing that fuel directly on the lunar surface, space agencies bypass the enormous cost of launching heavy liquid resources out of Earth's atmosphere. The math finally works in our favor. With a local supply of fuel available, the moon acts as an interplanetary staging ground for missions deeper into the solar system. Once the presence of ice was confirmed, the aerospace industry reacted. Combined with the maturation of cheaper robotic launch technologies, the data triggered a global chain reaction of lunar missions, commissioned by the US, by China, by Japan, and dozens of private commercial entities. The multi-billion-dollar Artemis program is the direct political and operational expression of the scientific data gathered in 2008. By detecting a subtle dip in a light spectrum, ISRO's Chandrayaan-1 mission overturned decades of settled science. It proved the resources were there, secured a potential launch pad to Mars, and brought the moon completely back into humanity's operational future.